Algebra 1, Day 64. Today we're going to be talking about graphing quadratic functions, things that have a highest exponent of x squared. So before we get into our official notes, I just want to make a few things, write a few things down so that way you guys could understand it a little bit better. I'm going to kind of define all of our terms and things like that so that way we can have a really good understanding about this. So first thing, quadratics. And quadratics are going to be anything, again, that has an x squared as the highest exponent. These guys are not lines. They're written in this fashion, where my a value is never equal to 0. This is called my standard form. Instead of graphing as lines, these graph as what is called a parabola. It looks something like a U or a V. It has a line of symmetry in the middle, and this is called my axis of symmetry. Now, this fancy axis of symmetry, this intersects my graph, or touches, at what's called my vertex. It also has an equation of x equals whatever the number is for the x value in that particular vertex. So let's talk a little bit more in detail about this. So if a is a positive number, my graph is going to look like this. It's opening upward, and my vertex is called a minimum. Yes, minimum. The reason is it's the very lowest point. However, when a is less than 0, also called negative, my graph is going to look slightly different. It's going to look like this, an upside down U. And my vertex is called a maximum. Why? Because it's the highest value we have. And the words minimum and maximum are referring to my y value. So how high up or how low down. We don't care where it's at on the x-axis. Okay, so I want to go ahead and identify just a couple of other random things, but we'll do that as we're going through our notes. So let's go ahead and take a look at these. A quadratic function is a function whose highest exponent is 2. A parabola is a U-shaped graph of what is called a quadratic function. So, how in the world do we graph these? Well, pretty simple. It used to be what we would do is we would say, all right, I'm going to take this, I'm going to plug in x equals negative 7. Everywhere I see an x, I'm going to go ahead and simplify it and write it in. And of course, I'll end up at some particular point, 8 for this case. Now, I can go through and I can do these all manually. I can also utilize my calculator to help me. We all know how to do the basic math. So I'm going to go ahead and I'm going to graph my question. So I'm going to call this the function for my notes, number 1. Let's go ahead and get that typed in there. All right, so my graph should look something like this. Looks like it's touching at approximately -5, -3. Those are my zeros. But more importantly, I want to take a look at the table. So Control T. All right, here's my table. So they're asking me to go all the way from -7 up to 0. So I'm going to head on up to -7. Okay, so 8, 3, 0, -1, 0. Whoops, hold on there. 3, 8. Now, I wrote down these values and I want you to notice something here. Here's a 0, here's a 0. How do I know that? Well, they're both located at a y value of 0, so that is an x-intercept. Now, the great thing about parabolas is they will mirror on both sides. Remember we said they had an axis of symmetry? So, 8, 3, 0, -1, 0, 3, 8. Okay, so they went down, 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 up, 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 up. So it looks like this might be some kind of vertex. Some kind of vertex here. Okay, so I'll just put a little question mark there. So let's go ahead and graph this. -7, +8, -6, +3, -5, 0, -4, -1, -3, 0, -2, +3. Notice the mirroring. -1, oh, excuse me, 0. Hold on, wrote the wrong value for 0. That'll be -1 and +8. All right, so there's my graph. I'm going to go ahead and draw in the remainder of it, but I'm going to leave it like this just so my points will be seen. These graphs we would do solid, of course. Okay, so there's my graph. Graphed it. So if I look at it, yeah, that certainly is a vertex. That is the point that's in the middle. So I'm going to label that as such, my vertex. Is it a bottom or a top? Well, it's at the bottom, so this is definitely a minimum. Now I can go ahead and start identifying other features. Let's see. From that point, I'm going to draw a line straight up and down. This is called my axis of symmetry. This is always located at x equals wherever it touches the x-axis. X equals -4. I have my zeros. And up here would probably be a y-intercept somewhere. All right, so let's continue to fill these out. So my x-intercept is where the graph crosses or touches my x-axis. We have all those other fancy words: 0, roots, solution. The x-intercepts for this particular graph are -5, 0, -3, 0. My y-intercept is where my graph crosses the y-axis. The y-intercept of this graph would have been located at x equals 0. So let's go back. We're going to find x equals 0, 15. 0, 15. 0, 15. The axis of symmetry. An imaginary line that cuts the parabola in half. The axis of symmetry of this graph is at x equals -4, as we established earlier. The vertex, and I sometimes refer to them as bottoms and tops, can either be a minimum or a top/maximum. The vertex of this particular graph was located at -4, -1. So let's write that in. And it is a minimum. It was at the bottom of the graph. Because my graph opens upwards. So if it opens upwards, I'm going to have a minimum. If it opens downwards, I'm going to have a maximum. All right. Same thing with this guy. Let's go ahead and plug this into my calculator. So I'm going to go ahead and go back over here. I'm going to add a new graph. I'm going to call this problem number 2 from my notes. Let's type in our values. -2x to the power of 2 plus 12x minus 16. All right. So notice how this guy opens downwards. Has a maximum. Okay. Here's a 0. Here's a 0. Let's take a look at that table. All right. So I'm looking for -1 all the way up to +5. So -30, -16, -6, 0, 2, 0, -6. Now, take a look at this. Up, 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 down, 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 down. So, up, 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 down, right? So it's going to open downwards and have a maximum. Now, I look at this, I see, oh, y-value is equal to 0, y-intercept. X-intercept. Also call my root or my 0. Now, I see over here, x is equal to 0, y-intercept where it touches. Always in between my two roots, if it has two roots, and we'll be talking about that another time, I'm going to find my vertex. This is more than likely my vertex, but I can't be 100% sure. Whatever that x value is, should be my axis of symmetry. But let's go ahead and verify that with our calculator. So I'm going to go ahead and close my table. And I'm going to go ahead and click Menu, Trace. And I'm going to go over to Graph Trace. All right. So let's see. So here that I identified my y-intercept. Let's keep on heading up. There's my 0 x-intercept. They gave me the point. Here is my maximum located at 3, 2, which is exactly what we predicted. My axis of symmetry is going to be x equals +3. And my other 0 located at 4, 0. So we can get all of this just by looking at a few points. So my vertex located at 3, 2. This is going to be my maximum. My axis of symmetry, x equals 3. My zeros are going to be located at 2, 4. 2 and 4, excuse me. And my y-intercept is located at 0, -16. Pretty simple and straightforward. We're just identifying the pieces, okay? So I want you guys to go ahead and get started on this, and I'll see you next time.